Okay, today's lesson is on relations and functions, or domain and range, I think is how I have it listed today. This is kind of pulling a bunch of different things together, some things that we need to review on what a function is, on what a domain set would be, a range set would be. You're going to see those vocabulary terms a lot in this unit that we are starting. And we're also going to review a bit of graphing. So I have a handout attached to our Google Classroom post for this because there's some graphs we'll be looking at. There's some graphs that we'll want to graph, and it's just kind of easier to see it. So we're going to be talking about a relation. That would be the set of pairs of input and output values. You can see a relation as a set of ordered pairs, a table, or a graph would represent a relation. So that's all that is if you see that term used in your homework. Domain we've talked about before. We definitely talked about it in the last unit. That's the set of all of your input values or your x coordinates. Your range would be the set of the output values or your y coordinates. Okay, we talked about domain when we talked about restrictions on what x could be and restrictions on what y could be in our previous unit with our rationals. All right, so you'll be asked if something is a function. So that would be a relation where each input has exactly one output. So that means you can't have multiple inputs for different outputs, or you can't have any x value being repeated. Okay. Visually, you can use a vertical line test on a graph to determine if a relation is a function. If a relation passes through more than one point on a graph, it would not be a function because a vertical line would have a repeating x value. All right, so that's our quick refresher for some vocabulary terms here. So if I'm given a table that is a relation, and I'm going to write the domain set. So the domain is all the x values. So my domain would be all of those values. All right, you must list them in order from least to greatest. And a set is going to be a curly bracket. Now I think in Math Excel they have the curly bracket there and you're filling it in, but if not, make sure you use the curly bracket from the keyboard. So -1, comma, in between each one, 4. I don't need to write 4 twice because it's already included as part of my domain. And then I would put 6, and then I would put 8. So if you put 4 twice, Math Excel could mark that wrong. The range set, I use the curly brackets as well to represent the set. And then my range will be the y values. And once again, they must be in order from least to greatest. Math Excel might mark it wrong if you don't put it in order from least to greatest. So -3 would be first, then 0. 2 is listed twice. I only need to include it once. And then 8 would be the set of my range. Would this be a function? No, this would not be a function because I have a repeating x value. So there's not exactly one input for every output. Okay. This next one, try your table partner. I'm just using my slides from when I usually do this in person, but we'll look at the domain one more time. Curly brackets, domain's all my x values. It's already in order from least to greatest for me. So -1, 0, 1, 2, and 3. Okay, the range, all of my y values in order from least to greatest, so -2, 2, 4, and 5. 5 is listed twice. You do not need to include it twice in your range. This is every different number of my range. Would this be a function? Yes. There are no repeated x values. There's a repeated y value that can still be a function. Okay. Next, I want to talk about interval notation. Maybe you saw this in your Algebra 1.5 or intermediate algebra class. Maybe you didn't. Maybe it's been a while. So just a quick refresher. So if I'm graphing this inequality on my number line, so 4 is what I want. I'll just put a number to the left and right of 4. So if it's equal to, I will need a closed circle on 4, and then greater would be everything to the right. Okay, so you'll have some problems in your homework. Well, they'll have the inequality, and then you are going to write it in interval notation. Okay, so I read a graph from left to right, so my starting spot is 4, comma, it's pointing towards infinity. It never truly ends, but it's pointing off to infinity. So then I use symbols. So I need that closed bracket or square bracket. That is when I have a closed circle. If I have an open circle, I use a parenthesis. Okay, or if I have a infinity symbol, I would use a parenthesis because it's not truly ever reaching infinity, it's continuing. So if it can be part of your solution or it is closed, we will use your square bracket. If it can't reach it or it is open, we will use that parenthesis. Okay. For the next one, x is less than -1. So let's just get a little bit of visual on this. I will have an open circle. Less would be an arrow to the left. Okay. So I'm still reading this from left to right. Now it's pointing towards negative infinity. So that's considered what I need to put first, because when I read it from left to right, it's going towards negative infinity, and then it stops at -1. So I need it in that order. So my infinity symbol is not always going to be to the right, only if it is a positive infinity. Okay, all of my infinity symbols will use a parenthesis since it's not going to truly reach infinity. And then this is an open circle, so I will use a parenthesis. Parentheses are more open. Your square bracket is more closed off, if that's a helpful way to remember which one to use. All right, one more option we could see in this form. So I've got, now it's saying we're between 1 and 3. 3 is equal to 1 is open, and then we're connecting in between. So this would be a case where I don't have any arrows like I did in the first two examples. So when I'm writing this in interval notation, we start with 1, we end at 3. I have an open circle, so I use my parenthesis. I have a closed circle on 3, so I use that square closed off bracket. Okay, that is interval notation. So you'll have some practice with interval notation in your homework for this lesson. We use interval notation a lot moving forward into pre-calculus and college algebra. Most of the Algebra 2 books will write, we're going to talk about domain and range soon, we'll use inequalities. So I'm going to have you practice writing both in our notes today and being familiar with both, depending on what class you move beyond this or what answer they're looking for on Math Excel. Okay, so the next part here, I want you to find the domain and range based on these graphs, and we're going to write them in both forms. So that's what these commas are for, so that you're familiar with both forms. So the domain, remember, those are all of your x values. So when I'm looking at this circle, I'm looking across the x-axis, so from left to right. What is the smallest x value? What is the largest x value moving from left to right? So that's as far left as the graph goes. That's as far right as the graph goes. So my farthest left is -2. My farthest right would be 4. So all of the x values must be between -2 and 4. There's my inequality. Or in interval notation, that would be -2, 4. No variable is needed when you're putting it in interval notation. That's why as we move up into upper level math classes, it's just a simpler way to write it. Okay, for my range, now I'm looking across the y-axis because that is for y. And so I'm looking at what is the lowest y value, what is the highest y value. So here's my lowest, there's my highest, everything is in between. Okay, so that means it must be between 0 and 4. This time I put a y, everything is equal to, it's all solid, and so as interval notation, that would be 0, 4. Is this graph a function? No, it is not a function. It would not pass my vertical line test. It would go through more than one x value with that line. Okay. For my next graph here, my line over at the right. So if you notice, there are arrows pointing to the left and right and slanting up and down. So for my domain, what that would mean is when I'm looking across the x-axis, what's the farthest left it would go? Well, that's towards negative. Oh, I'll keep it consistent. The farthest left it goes is towards negative infinity. The farthest right it goes is towards positive infinity. Both need to be parentheses since we can't reach infinity. And my domain then, the other way to write that would be all real numbers is what we've used in the past. So we're not going to write them as inequalities. It's either all real numbers or that's the interval notation way to write all real numbers. For my range, I'm looking across the y-axis, so what is the farthest down it goes? Well, it's pointing down towards negative infinity and up towards positive infinity. So same thing, all real numbers for the domain and range. Is this a function? Yes, any slanted line is going to pass your vertical line test. So typically all lines are functions unless they are a vertical line. Okay, we'll look at two more graphs here. So we've looked at absolute value graphs before, and we also talked about their range before. For my domain, I'm looking across the x-axis. What's the farthest left it goes? Well, it points towards negative infinity. The farthest right, it points towards positive infinity. So that is all real numbers for my domain. For my range, the lowest it's going to be is 1, 2, 3, 4, 5. So -5, and that's solid, so square bracket. And the highest it's going to be, it's pointing up forever and ever, so that's towards infinity. So that means all of my y values must be greater than or equal to -5 is how I would write it as an inequality. Is this a function? Yes, it would pass my vertical line test. Okay. Last graph we'll take a look at. For domain, I'm looking across the x-axis. So this is the farthest left it goes, but then it points off forever and ever to the right. So that means we're starting at 0, we're ending towards infinity. 0 would be solid, infinity we can't reach. My domain then would be x must be greater than or equal to 0. As a range, so I'm looking across the y-axis, so I'm trying to find the highest and lowest it goes, but it's going to continue forever down and forever up. So we will have all real numbers and negative infinity to infinity, both parentheses around your infinities. Would this be a function? No, it would not pass my vertical line test. I would have repeating x values. Okay. All right, we're not doing that. That would be an in-class, in-person thing. All right, so we're going to graph these following functions. We have graphed lines, we have graphed parabolas, and we have graphed absolute value graphs before. So we're just kind of going off of some review because we'll be doing some more graphing in this unit. And so this is a line that's in my form y equals mx plus b. The hope is at this point, when you look at that, you do know that that equation is a line. I'm crossing the y-axis at 4. 1, 2, 3, 4. My slope is -2, so I'll go down to right 1. And then you'll just kind of, just like we did in before, you'll plot a point, you'll plot another point, and you draw that line on Math Excel. All right, so then I can find the domain. My domain stretches forever in the left and right direction, so all real numbers. My range, this line stretches forever, going up and down. And then this would be a function. All right, so the idea is that we wouldn't always have to graph this, and that I could look at this and I know that's a slanted line, and so I know the domain and range would be all real numbers, and I know it would be a function. Okay, but we could also graph it to double check. All right, then this next one, see if you remember how to graph a parabola in this form. So if you don't, certainly can make a table, but my vertex would mean I'm moving right 2, and up 4. So my vertex would be the point 2, 1, 2, 3, 4. Then there's a certain pattern about this parabola shape that it's going to make. Maybe you remember that pattern. Over 1, up 1, over 2, up 4, 1, 2, 3, 4. If you remember that pattern, great. If you do not, my suggestion was to always plug a value. So this is 2. So if I test something like 3 and I plug that in, 3 minus 2 would give me 1. 1 squared is 1, plus 4 would give me 5. So when I plugged in 3, I got 5. So 3, 5 is right here. Match 1 on the other side. If you remember, we talked about that axis of symmetry to help you match your points. In Math Excel, usually you had to graph the vertex first and then put either 1 or 2 points after that, depending on which problem. Some of them had us do 3 points, some of them did 2 and make the parabola. Okay, so my domain, we talked about domain when we did these problems as well, way back last quarter. So my domain would be all real numbers because it's stretching forever in the left and right direction. My range, that is my lowest y value, which is 4, and then it points off towards infinity. Or y must be greater than or equal to 4 is how we wrote it when we were in that chapter. Both are correct, and this is a function. Okay, for number 3, very similar to how we graphed these. You had a vertex that tells you move left 1 and down 3. If you did not remember this, then you go ahead and make a table. 2, 3. The negative is a reflection, so this is flipped over, and then it was in over 1, left 1, down, or sorry, down 1 and left and right 1 with each. If you remember that, otherwise test a point. Like I said before, we've got 1 is my x, so you could test 0. 0 plus 1 would be 1, so negative 1 minus 3 would be a negative 4. So right there, match a point on the other side. This also had an axis of symmetry. Okay. All right, then for my domain, same as my parabola, we'll have all real numbers. It's stretching forever from left to right. Range, I've got a highest point, and then it's stretching forever down. So I'll have students that will mix this up. So negative infinity to negative 3 would be how I would write that, because you have to go from the furthest down up, or y must be less than or equal to negative 3. Okay, is this a function? Yes, it would pass my vertical line test. Okay, all right, so the last part, my suggestion is to try to figure this out without graphing. If you want to graph, you certainly can. You've got graphing calculators. You've got Desmos that I showed you last quarter. If you don't have a graphing calculator, so desmos.com if you want to see this. But the idea is that when I look at this equation, it's got something squared, that's a parabola. So what are the domains for all of my parabolas? Well, that's all real numbers because they stretch forever left and right. We just graphed an absolute value graph that makes a V shape. In this case, it was upside down, but it doesn't matter if it's upside down or right side up. That domain is going to stretch for all of my x values forever to the left and right. So that's all real numbers, or I should put my other form as well. Okay, this is in that form y equals mx plus b. That's just a line. It's a diagonal line, so all real numbers then, negative infinity to infinity. And then we get to the next 3, and those are graphs that we haven't had much experience with. So you can graph and see what this does. Kind of makes a shape like that, you would find out. So the domain is all real numbers, but something else that you can notice is we need to think about with, as x being your input, is there anything I can't plug in and raise it to the third power? Is there anything I can't plug in and multiply by 6? No, you can plug in any number you want. Same thing with up above, I can square any number I want. I can put any number I want inside of an absolute value. I can multiply any number I want times 5. Okay, and you might be wondering where I'm going with this. Well, I can't put any number I want inside of a square root. So there's going to be a restriction on that domain. And that's what we started talking about in our last unit, restrictions on domains, like number 6. Okay, so my domain then, well, I can't take the square root of negative numbers. So that means all of my values for x must be greater than or equal to 0. Or that would be 0, infinity in my interval notation. Okay, so I don't even have to be familiar with this graph. I need to be familiar with that equation and what I cannot plug in. Number 6, same thing here. In our last unit, we said things like, well, that would be all real numbers except x could never equal -2. We won't write it in an interval notation form. Just this way is fine for right now. Okay, so if I have an x in my denominator, that means I'm going to have a restriction on what can be in the denominator. If I have a square root, I'm going to have a restriction on what goes in there. Everything else will be all real numbers for your domain. So those are the two situations where we're going to have restrictions on the domain. Okay, so we'll talk more about that in our upcoming lessons. But you should be able to get started with your homework. There are quite a few problems on this assignment, but some of them are just you're answering yes or no if it's a function or not, or you're just typing in the x values or the y values. So I don't see it being super long. Good luck.